Hey, I'm just going to make a few comments and we'll look at it in class. We didn't spend a lot of time in the other sections on this. We answered questions and went over a few things. And what we're doing on Monday is pretty limited also. Things really begin in earnest on um, Wednesday. Earnest in the sense of calculations and um, those sorts of things. But there are a couple of things I want to point out about population and sample. I'm going to give you the formal definition. A population is a collection of all outcomes, responses, measurements, or counts that are, and here's the here's the word that I just don't agree with, which is are of interest. Um, no. The population is the largest group that you may be interested in, okay? But it's the largest group that you can legitimately, with support, say something about based on your survey, your sample, your experiment, your work. What can you talk about? Who can you talk about based on your research? So, and a sample is just any part of that population. Right? It's who you're talking to. The sample is who you're talking to get information. Right? Statisticians are really interested in the big group. Let's say you're a quality control engineer and you're, looking at my battery um, powered headlamp, and you're responsible to make sure that the batteries that are sold, you know, conform to whatever guarantee is on the packaging. These will last 2 years. So you have to take some batteries that you're producing, not all of them, and test them. That's your sample, the ones you're actually testing or the ones that you're actually looking at. But what you're interested in is all the millions of batteries that you're selling um, that you're not testing, right? But you have to be able to say, look, we conducted a good study and we are able to say something about the batteries we're selling. So um, here's my metaphor for sampling. It's cooking. Um, and let's say you go into a big commercial kitchen. It's giant. There are 20 stoves with 6 burners each, and there's pots all over. There's 100 pots, all soup. This is a soup establishment, and you don't really know anything beyond that. That it's soup. And then you take a spoon and you go to one pot. Now it's a giant pot, right? It's a giant commercial 10-gallon pot. You take a little sampling spoon. You stir it all up. Take a little sip, and you say, "Oh, this needs a little bit of salt." Now, you're able to say by this, you're able to say based on your sample, a little tiny spoon, right? Just a little bit of soup out of this 10-gallon pot. You're able to say this pot needs some salt. Now, what about the next pot or the pot way down there, right? You may not want to do all the work, to collect data, right? You may be interested in a shortcut, but that's not going to work. I'm sorry, right? That's not going to work. The only population, the only soup that you are legitimately able to say something about, knowing nothing else, is that pot that you just sampled. That's your population. Now, if you set up some sort of a method where you test every third pot and then you may be able to say something about the kitchen. Like, well, we sampled 27 pots, and here are our findings of these 27 pots. We're now going to say this kitchen. I hope that metaphor makes some sense. If it doesn't, come in, bring a question in on Monday or Wednesday or whenever the question comes up. All right, so what we're going to do is I'm just going to look at one or two of these and and answer the question. Identify the population in the sample. Describe the sample data set. Let's look at number 25. A survey of 1,020 U.S. adults found that 42% trust their political leaders. Okay, so Gallup is a United States company, to the best of my knowledge. And what I'm going to ask is, I'm going to ask for 3 pieces of information. Describe the sample, and you may have to answer questions about that. Give the size of the sample, and then, to the best of your knowledge and support your answer, give the population. Well, I'm going to start with the sample. Sample is U.S. adults. So if I were to ask, were any Danish citizens surveyed? And you'd say no. And I say, how do you know? Well, it specifically says they were U.S. adults. Were there any children here in Parkland questioned about their political leaders? No. Why not? Because it specifically says U.S. adults. How about Canadians? That's close, right? That's close. No, it says U.S. adults. How many? So that's a description. Adults that live in the United States, and there were 1,020 of them. That's the size of the sample. But U.S. adults, size of the sample is 1,020. Now the population, again, going back to the soup thing, what is the Gallup agency, what is the Gallup company trying to understand? American adults. Are they legitimately going to be able to say that they now understand the relationship of adults in Algeria to their political leaders? Well, that makes no sense. You talk to U.S. adults. How would you know what people in Algeria think? You didn't, I mean, you have no connection to that. U.S., not even Canadians that are pretty close, right? So I'm going to say, even if you wanted to know more, the best you can do is now say something about U.S. adults. There's 200 million of them. You're now going to be able to say that something about adults in the U.S. That's your group. That's your population. That's your pot. Not Canada. You can't go up to Canada. That's that pot over there. You didn't sample that. No, can't go over there. All right. Now, the next one is interesting because 203 human infants were surveyed, and it sounds like it's just babies. Like, oh, we're just human babies. And I'm gonna say no. I have to read further. A study of 203 infants was conducted to find a link between fetal tobacco exposure and focused attention in infancy. I'm going to say that when the infant behavior and development people who conducted this study, when they published their results, what they were really interested in is not human babies, generic human babies, but rather all human babies that had been exposed to tobacco in utero. Yeah, that's who they're really interested in. They are interested in not American babies, not Canadian babies, not white babies, not Northern Hemisphere babies, human babies who had been exposed to tobacco in utero as fetuses, right? As embryos. So that's what I'm getting the feeling for, is this. I had to read the whole thing and say that. And if you look at it's hard going back. And here's one that I like, number 30. A survey of 496 students at a high school found that 95% planned on going to college. This is another one where there's lots of high schools, but they went to one high school. It's one pot, and I don't think they can say anything about that in the high school down the road, because who knows? We don't know, right? That might be a high school that, even though it's nearby, that the students are drawn from a different parts of town, different zip codes. Literally, they're going to have different socioeconomic backgrounds, and that's going to influence their attitude toward going to college. So the sample is 496 students at a high school. One high school, we don't know what it is, but the high school, that one. And the population is all of the students at that high school. The researchers are now going to be able to say at parent-teacher night, well, what we found is that 95% of our students, again, 95% of our students, they're just talking about the student population, are planning on going to high school, or college, excuse me. All right, when it comes to data classification, all I want to say is this. Digits, right? Here are digits. Here are digits. There's 10 of them, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Digits are not numbers. Look at the video, the PowerPoint, and even the text and the video. You see some examples of, data at the nominal, ordinal, interval, and ratio levels. Okay. My emphasis is this: just because digits are involved doesn't mean you're dealing with legitimate numbers. And here's my example. Here's the example I love. As I mentioned, I'm going in for surgery, and typically, later, typically first thing when you get out of surgery, the healthcare provider, typically a nurse, is going to come by and say, "Oh, hi, how are you? Good. I'm glad you're out of surgery. How are you feeling?" And then they will get their little clipboard. What is your pain level? And to me, that is a nonsense question. I understand they have to give it. And so here's what I'm saying. This is what you'll see. There's a little card often. What's your pain level? On a scale from 1 to 10, 0 being no pain, and 10 is pain as bad as it could be. Where are you on that? That's, to me, nonsense, right? Because here, first of all, you can look up above and see that there are words that are being used. And if you look at this slide, right, you don't need the numbers. You don't even need the words. You could point down here in the blue and say, blue, I'm feeling great, or red is, ugh, that's awful. Yeah. So when the healthcare provider comes in, of course, they are going to have to report a number, but ask them, it's usually a little card. They have a little card. Say, please turn the card over to the children's side. Because again, up here is this nonsense ordinal level. These numbers, what do they mean? What's a 7? 7 what? Or a 3, right? And I'm going to give the one that I really like. These pictures that have color and facial expressions, right? Here's the thing: is these digits at the ordinal level of measurement don't work any better and have no more meaning, none, than these words or these pictures, right? You can have a child where 4 doesn't mean anything, and they can say, you can say, were you crying a little bit? Did it hurt that bad? No, but I'm sad. I feel sad because it hurts. Or you might walk in and they're just unable to stop crying. Like, okay, we're going to go with a 10. I mean, I have to report a 10. But you see, this is information. This is nonsense. And the whole idea that going from, well, or even here, going from kind of frowny, it's and 2 steps away, you've got like, okay, every once in a while a tear will come down. And then 2 more steps, and then you're uncontrolled. Like, what? Makes no sense. Anyway, digits are not numbers necessarily. And be very careful about then saying, well, I collected numbers and I'm going to find their average. I'm going to multiply them. I'm going to take the square root and find the variance and things like that, or whatever sentences that you're saying. I go, numbers. Numbers. We're going to do math. Say, okay, if you collected number data from your patients, then I'm going to say, okay, you got a 4, and an 8 and a 10 and a 2. So I'm going to ask, what's kind of a small smile plus a frown plus one tear and plus uncontrollable tears? What's the average of those? Tell me how you add those up and divide by 4. Or what's the variance of 2 of these, 1 of those, and 1 of those? So it makes no sense. All right, I will see you tomorrow morning.